But this was designed for a microwave oven. So it essentially can control all the functions of a microwave oven. I can say things like, voice genie, defrost 1 pound of chicken. And as you see, it's figuring out what it was that I said. Oh, it's still listening to me. So, and then result. And it would have had the microwave oven start up and prepare that meal for me.
Hello IPX. We're here with Alif Semiconductor and Henrik again. Please refer back to his definition of what AI actually is.
Oh, that depends a little bit. Sometimes you wake up in the morning and the definition of AI is a huge cyborg from outer space pursuing you relentlessly. But I think really the kind of common definition these days is that AI is essentially when you're able to ask a machine a question that you have not given it the answer to previously, and it's able to figure out something that seems like it could be an answer to that question.
Very interesting. So when we've been talking to people, it comes across that it's almost like it's a data set. They have a definition for that data set is the data that comes in, which has been mainly camera at CES, that's what we've been looking for. It recognises it, and then it gives feedback and says, I found that. Going by you, that's not AI.
Well, it kind of could be, but there's different things, right? You can do AI on vision in the way that you describe, but this can also be applied to things like voice or sounds or movement of fluids through pipes or electric current going through circuit boards and things like that.
Now we're going to look at some of their demos that they've got at CES. So we actually see those 32-bit microcontrollers actually in action using AI and low power AI. So Henrik, over to you.
Thank you so much. So maybe we start from this side here. When we go to shows like this, we like to bring examples of our evaluation boards that our customers can use when they want to explore our hardware capabilities, how our software works, and to kind of get ideas for how they can put their systems together. And we like to bring them, if we can, together with some solutions that we have created together with partners. So I have two solutions like that here. One here is a natural language library that we put together with a company called Sensory. They designed these type of libraries that can be installed into things like appliances so that you can do voice control for all the features of the appliance, but you don't need a cloud connection for it. Everything is actually decoded and parsed on the device, and it's very responsive. You can talk to it as if it is, it's not 6 keywords that it understands. It understands complex sentences and it can make sense of them.
How many languages
This particular one only understands English, but that can potentially be extended. I'm not an expert in that particular domain.
Just interested.
That's for them.
Right, okay.
But this was designed for a microwave oven, so it essentially can control all the functions of a microwave oven. I can say things like, voice genie, defrost 1 pound of chicken. And as you see, it's figuring out what it was that I said. Oh, it's still listening to me. So, and then result, and it would have had the microwave oven start up and prepare that meal for me.
Right. So in that case, that's their software running on your chip?
Correct.
Right. Okay, good.
And this is surprisingly complicated to do on traditional microcontrollers. Decoding a single keyword, that is not super complicated, but being able to distinguish between a string of words, put together the words that are kind of, here is what I'm talking about, here is the command that I want you to do with the thing that, there's a lot of math that needs to go into that. So this is something that the way that we've designed our devices with built-in neural processing units, you can offload those neural networks on the accelerators, run them there, makes it so much faster in terms of latency and response from whatever it is you're talking to.
Right. So the key with your AI there is speed.
In this instance, yes, speed and just capability of having a larger vocabulary, because we have a ton of memory resources in here too that you won't find in a traditional kind of legacy microcontroller. So we can have a much broader understanding of language.
And in normal applications like language, is there a trade-off in those two things?
The larger the vocabulary, the more intense the data processing will be, because you have a bigger data set that you have to go into whenever you do the computations. So to be able to do it faster becomes more important as the vocabulary grows.
Right. So language in this case is a true AI application because it's thinking as you do it and it's waiting and then it's interpreting the language.
A lot of the AI nuances in an application like this comes from actually being to recognize the words that are being spoken to the system, because people have different accents, they have different intonations, and that is difficult for a computer to be programmed to understand. But with artificial intelligence, you can kind of fuss that. So, even with my accent, it can figure it out.
You don't have an accent. So Century partnered with you purely because because that power was less of an issue with this application. Just as an example, this is obviously a plugged-in power rather than.
Correct. It's actually running off a battery here. This is a little USB battery pack that we're driving all of these from.
Yeah.
And when we collaborated with them, they saw great potential in the efficiency that we have in our systems for applications like this. They'd been using traditional microcontrollers or big microprocessors before, and they thought that, hey, I can do this with a much smaller device, lower cost point, simpler to design with.
Cost was key here too. Yeah. Okay, good. Next one.
This is from a company called Plumer AI that we're working with, and they have a number of essentially off-the-shelf machine learning solutions that people that are interested in adding this sort of technology to their designs can acquire from them. This is a presence detector. So there's a camera attached to this board. As you can see, it identifies that I am a humanoid and I'm standing in front of the camera. If you move a bit closer to the frame, it will be able to pick out you as well.
They're not recognizing me as a humanoid, so we have a problem.
There's a question mark right
there
over
really is a question. There's been a question mark over me for many, many years. But anyway.
I think you might have to get in a bit closer.
There we go. Oh, I'm a human. I'm a human. Yes.
Certified.
Okay, good. Excellent.
But the key thing with this demo here, if you look at this inference speed, so we're running inferences using this demo at over 80 frames per second.
Right.
On some of the other platforms that this model supports, that inference stays kind of around the 10 frames per second level, which is, it kind of shows that it works. But if this is meant to count people moving in and out of a room in a building in order to know whether I should keep the HVAC system on for that room, if you're walking fast, it won't detect you because it doesn't have enough horsepower to actually keep up with the traffic flow.
Let's just come back to that. Let's just come back to that point when we looked at this one. So let's look at this one here as well.
Yeah. We can do that. This is an object detection demo. Right now, the object that it's detecting is faces. You can see we're both looking at it. It says that it's detected 2 faces.
Yeah.
So this is trained on what a human face looks like. It draws a little bounding box around that on the screen, and it follows that along as you move in front of the camera. Yeah. And the same thing here. We're running inferences at less than 7 milliseconds per inference on the image data coming in. That means that we have about 150 some inferences per second. Okay. So we can track them very accurately.
Right. So if I were going to summarize what's very interesting about all three of them, they're all interesting. They're all doing their own individual things. But the key thing here is speed.
Is correct.
So you wouldn't have expected to be able to do that with a 32-bit under the engine.
That's right. But with the speed, if you kind of turn that around, you also get battery life, because it means that I did the heavy processing really quick, and then I can go back to sleep. And I can sleep longer, and the battery lasts for months instead of days.
Right. Yeah. So for our people looking for disruptive technology in ipXchange, it's where you're looking for very high data analysis with a battery, which you'd normally have to expect to spend a lot more money to get that speed of data. But because you're doing it at a low power, you can do it with a battery and get the performance that you'd expect to have. You'd probably have to expect to spend a lot more money on.
Correct.
Right. Okay, good. And all of these are available as dev boards?
Exactly. So these are based on a platform that we call our AI/ML AppKit. The AppKit is for essentially doing application-focused evaluation of our technology. So we don't bring out all of the signals from the microcontroller on these boards, but we provide very rich SDKs that make it easy for people to kind of from a software side experiment with
and
this.
They come embedded with the software, so they can just plug it in?
Yeah, we have a public GitHub where we publish all of the demos that we create for these boards. So people can go there, they can download the demo, they can run the demo, and they can dig into it, remove the things that we did, put in whatever model they want to run, see how that behaves.
Right. So it's an important question for our community is volumes, because I would imagine that if somebody, this is in highly industrial environments and consumer. So what sort of volumes do you feel that you're prepared to support with this kind of dev kit if our community wants to come to you and say, I think you can solve my problem? Are we talking 10,000 up?
So Our go-to-market strategy is broad-based to distribution. Our key distribution partner is Arrow Electronics, and we are set to be successful in that go-to-market strategy. And that means that we have to kind of have our logistics rigged for aggregating a lot of business from a lot of customers through those channels. We see success at around, maybe 100 million units shipped per year. So 10,000 units, not a problem at all for us.
Right. Okay, good. So if you've got a project and you think it's around about 10,000, you can either go to ipXchange.tech, that would be ipXchange.tech, ipXchange.tech, to get hold of one of these boards.
Fantastic.
Excellent. Thank you, Henrik.
Thank you, Guy.
Hey, where my engineers at?